Hi class, this is lesson 4.7, complete the square. So we are going to be using another method to solve equations, and this is called completing the square. So you know how to solve some equations using square roots. We've done this, so let's solve this one right here. I've got x minus 5, the quantity squared. So to get rid of that squared, oops, I need my pen here. I need to take the square root of both sides. So that leaves me with x minus 5 equals positive or negative 7. So I have positive 7 or negative 7 that is both equal to. I've got two possible answers. I can say x minus 5 equals 7, or I could say x minus 5 equals negative 7. And then to find my answers, I can add 5 to both sides. So I have x equals 12, and if I add 5 to both sides here, x equals negative 2. So those are my two possible options. And that's one way to solve if you have a quantity squared. So notice what we want to know here is if our left side is a perfect square trinomial, well then we can factor it to get it in this form. We can say if we have a binomial squared equals a number. So we're going to try to do this factoring. We're going to try to make them into a perfect square trinomial so that we can do this. And here's an example of what I mean, what I want it to look like. So this, I have x times x here, and out here, that's 10 times 10, and 10 plus 10 gives me my 20, my b term. So I know this factors into x plus 10 times x plus 10 equals 81, or really that's x plus 10, the quantity squared, equals 81. And then this is easy to solve, just like I did in the problem above it. I take the square root of both sides, and then find both of our answers. So I've got x plus 10, the quantity squared, equals 81. Take the square root of both. So x plus 10 equals positive or negative 9. So I have x plus 10 equals 9. X plus 10 equals negative 9. I can subtract 10 from both here. So I have x equals negative 1. And subtract 10 from both sides here. X equals negative 19. So see, I could get my two answers there by factoring the first problem, or my original problem. It's not always like this though, so what we're going to learn how to do is make it so that you can factor it in this form. Alright, so here's the steps that we are going to follow. So if your equation is not in the form of a binomial squared equals some number, so you can take the square root of both sides, you can rewrite our problem using this process, completing the squares. Okay, so our first step, we're going to write our equation. So my equation that I'm going to use is x squared minus 10x plus 1 equals 0. So my first term is x squared, but my last term 1, well that is a perfect square, but 1 times 1, the 1 plus 1 does not add up to negative 10. So I need to move that 1 to the other side. I'm going to subtract 1 from both sides. So I move my constant to the other side, and I'm going to make one side x squared minus 10x equals negative 1. Now I'm going to focus on the left side here. I'm going to complete the square, and then I'm going to add my square to both sides. So I know this is x times x, and the square that I'm going to use is half of this number. So half of negative 10, well, it would be negative 5. If I had negative 5 plus negative 5, that would give me negative 10. So you do negative 5 times negative 5 to give the number that you want there. So I want plus 25 here. So I'm going to add a plus 25 to the left side, but if I add it to the left, I have to add it to the right side as well. So this leaves me with x squared minus 10x plus 25 equals 24. So now I want to factor this side since I now have a perfect square trinomial. I can factor this into x minus 5, the quantity squared, equals 24. Now this looks just like the problems up above. I can take the square root of both sides. I have x minus 5 equals positive or negative. Now we've got to think 24. Are there any perfect squares that go into 24? Well, yeah, there is 4. It's the square root of 4 times the square root of 6. So I've got x minus 5 equals positive or negative 2 square root of 6, and I can't simplify that anymore. But on the left side, x isn't all alone, so I need to add 5 to both sides. So that cancels. I have x equals 5 plus or minus 2 times the square root of 6. Okay? So one thing you could do is check by graphing. You could plug 5 plus 2 square root of 6 into your calculator and simplify it, and 5 minus 2 times the square root of 6 into your calculator and simplify, and then check to see if that works when you graph it. See if those are where your intercepts are. Alright, let's complete the square on these bottom two here. Now let's just think about what we would need for our C in order to make these perfect squares. We're not going to go through and solve these at all. So number 1 here, my B term is 28x, so you have to think, what's half of 28x? Well, that's 14. So if I split this up into 14 times 14, 14 times 14, that would be the C that I would want. So I would want C to be 196. And if I had C be 196, I could say x plus 14 times x plus 14, which would really be x plus 14, the quantity squared, and that's when C equals 196. So I suggest for number 2, you pause the video and try it on your own. Try dividing your middle term, your B, by 2, and then multiplying that together by itself to get your C. Okay, so if I split negative 9 into 2, I would have negative 4.5 and negative 4.5. That's by splitting that in half. So negative 4.5 times negative 4.5 will give me my C. Negative 4.5 times negative 4.5 is 20.25. I'll say that again. That's negative 4.5 times negative 4.5. That's multiplying our two factors together. So I've got x squared minus 9x plus 20.25. I've now made this a perfect square trinomial. It factors into x minus 4.5, the quantity squared. You could write x minus 4.5 times x minus 4.5 out, and then rewrite it again, but really just simplifies into x minus 4.5, the quantity squared, and this is when C equals 20.25. All right, let's flip it over and look at the back side of these notes. Okay, so now we're going to do some solving when the coefficient of x squared, so the number in front of x squared, is not 1. We're going to need to make the coefficient of x squared into 1, and we can do that by dividing on both sides. So looking right here, 3, negative 36, and 150, 3 goes into all three of those. So if we divide all three of these by 3, since they're all divisible by 3, that will make our first coefficient 1. So I'm going to divide this piece by 3, divide this piece by 3, divide this piece by 3, and I'm going to divide this piece by 3. Everything on both sides I'm going to divide by 3. Since I'm doing it to everything on both sides, it's perfectly fine to simplify that way. So this one first would give me x squared minus 36 divided by 3 is 12x plus 150 divided by 3 is 50 equals 0 divided by 3 is still 0. Okay, so now we're trying to complete the square. Half of our b term is negative 6. Negative 6 squared is not 50. So I need to move that 50 to the other side by subtracting it. So I have x squared minus 12x equals negative 50. Now we've got to find half of our b term. So if I split that in half, I'd have negative 6 times negative 6. Well, that's positive 36. So I'm going to add positive 36 to the left and positive 36 to the right. So I'm completing the square right there. Okay, and I found it by dividing my b term by 2 and then squaring that number. So I now have x squared minus 12x plus 36 equals negative 50 plus 36 is negative 14. So I can now factor this. That's x minus 6, the quantity squared, equals negative 14. And I'm trying to solve the original directions were to solve it. So now let's solve it. And I'll rewrite it over here. So to solve this, I've got x minus 6, that quantity squared, equals negative 14. To solve it, I take the square root of both sides. Oh, I'm taking the square of a negative. I'm going to have an I. So I have x minus 6 equals I. Now, square root of 14. There are no perfect squares that go into 14, so it needs to stay times the square root of 14. But x is an Alonia. I need to add 6 to move that 6 to the other side. So x equals 6. Now, when I take that square root, one thing I didn't put was my plus or minus sign. So it's 6 plus or minus I times the square root of 14. And there are my two answers. I'm going to leave it just like that. 6 plus or minus I times the square root of 14. My next one here says the area of a triangle is 144. What's the value of x? Well, we need a little more information here. So let's draw a triangle in here. So here's my triangle that we're talking about for this situation. This is a right angle right here. The bottom is x plus 10. And the height here, the whole height is 2x. So let's keep in mind area equals half base times height. Alright, so I've finished putting the information that was missing in this problem. Let's solve it now. So my area is 144 equals 1/2 times my base, that's x plus 10, times my height is 2x. Well, I can multiply these together. Half times 2x, that's just x, times x plus 10 equals 144. Okay, now I can't solve it this way yet. So what I want to do is distribute my x. I'm going to have 144 equals x squared plus 10x. And now I'm going to use completing the square so that I can factor this a little bit better. So here's my b. Half of positive 10 is 5. So I'm going to have 5 and 5. 5 times 5 is positive 25. So I need to have positive 25 to the left and positive 25 to the right. Positive 25 to both sides. So now I've completed my square. I have 144 plus 25, that's 169. I'm going to move this right over here. Equals x squared plus 10x plus 25. So this is really 169 equals the quantity x plus 5 squared. I'll solve it by taking the square root of both sides. So I have positive or negative 13 equals x plus 5. So I'd subtract 5 from both sides. I'm going to move I ran out of space here. So I have x equals, I can do positive 13 plus 5, or I can do x equals negative 13 plus 5. So this one gives me an answer of 18. This one gives me an answer of negative 8. Now the question's asking what's the value of x, and if I'm talking about a side length, I can't have a negative number, so this isn't possible. It's got to be positive 18. What did I miss? Oh, I minus 5, so it should be 13, not plus 5. It should be minus 5. This should be negative 13 minus 5. Leave me with negative 18, which still isn't possible. Or 13 minus 5 is positive 8. So that leaves me with C right here. See how I noticed I did something wrong, because that was a multiple choice question and my answer wasn't there. So I can't just make my own answer and leave it there. I have to figure out what I did wrong so that I can get one of those problems or one of those numbers as my answer. Alright, almost done with these notes. Just got a couple more problems here. I'm going to move this up a little bit. It says you can convert a quadratic equation into standard in standard form into vertex form by completing the square. So that's really what the whole purpose of completing the square is, besides solving, is changing an equation into vertex form. So standard form, recall standard form looks like this. Y equals ax squared plus bx plus c. And then vertex form looks like this. Y equals a times the quantity x minus h squared plus k. So vertex form allows us to look at it and quickly tell what the vertex of our quadratic form, or our quadratic equation is. H is the x value of your vertex, k is the y value of your vertex. And it tells you how far your graph has moved left or right, or up or down. So let's convert these into vertex form. And we want to do that by completing the square. Okay, so in order to do this, we need to have this equal to 0. So I'm going to put 0 in for y. So x squared plus 18x plus 95 equals 0. Now I want to make it in vertex form. So I need to complete my square. I need to move my 95 to the other side. So I have x squared plus 18x. I'm going to leave space, equals negative 95. So to find what number I need to add to both sides, I do half of b. Half of 18 is 9. So 9 times 9 is 81. So I've got to add 81 to both sides. I found that by doing half of b and then squaring it. So 81 is what I added to both sides. We can't forget to add it to both sides. So this factors into x plus 9, the quantity squared, equals negative 95 plus 81 is negative 14. And I can now move my negative 14 back to the other side, because notice in vertex form we have a plus k at the end. So move that 14 to the other side, and I end up with 0 equals the quantity x plus 9 squared plus 14. And instead of, since I'm not trying to solve this anymore, I just want the standard form, I'm going to say y equals the quantity x plus 9 squared plus 14. And there is my quadratic equation in vertex form. That's how I can use this. Now, you should be able to tell what's the vertex here by this. So our vertex, well, it's x minus h, and here I have plus 9. So our vertex is negative 9, comma, and the k is at the very end, and that's 14. So our vertex of this equation would be negative 9, 14. In a vertex, the bottom of the v, or of our quadratic, of our parabola, that moved to the left 9 and up 14. So our transformation we would say left 9 and then up 14. There's our transformation. One more problem here. Let's change this one into vertex form as well. So it is x squared minus 14x plus 56 equals 0. Well, half of 14 is negative 14 is negative 7. Negative 7 squared is not positive 56. So I need to move that 56 to the other side. So I have x squared minus 14x. I'm going to leave some space for my c equals negative 56. So I've got to think, what do I have to add to both sides to complete this square? Well, half of negative 7 or negative 14 is negative 7. Negative 7 squared is positive 49. So I'm adding positive 49 to both sides. Okay, so that's what I added to both sides. I put it in a different color. Remember, we do it to both sides. So my left side factors into x minus 7, half of b, the quantity squared, equals negative 56 plus 49 is negative 7. Now, I want to put this in vertex form, so I need to have everything on the same side. I'll add 7 to both. So I have x minus 7, the quantity squared, plus 7 equals 0. So in vertex form, it's y equals the quantity x minus 7 squared plus 7. So my vertex, here's my vertex form. It's minus h and plus k. It says minus 7, so I just plugged a 7 in for h, and then positive 7 in for k. So my vertex here, my vertex is the point 7, 7, and my transformation well, my vertex moved to the right 7 and up 7. So my transformation is right 7 and up 7. That's the transformation of my graph. And this is the end of the lesson. Make sure you have if you had any questions, you star them so that we can talk about them in class tomorrow, and have a fabulous night.